Welcome to this deep dive into advanced AI coding with GitHub Copilot. Today, we're going beyond basic autocomplete to explore 4 powerful features that can truly transform your development workflow. MCP servers for external tool integration, custom instructions that enforce your team's standards, intelligent memory that learns from your codebase, and custom commands that automate repetitive tasks. Whether you're a solo developer or part of a large engineering team, these features will help you write better code faster, maintain consistency across projects, and leverage AI in ways you might not have thought possible. Let's jump in. What is MCP? First, let's talk about the Model Context Protocol, or MCP. This is a game-changing open standard that allows AI models like GitHub Copilot to interact with external tools, services, and data sources through a standardized interface. Think of MCP as a universal translator between your AI assistant and the rest of your development ecosystem. Need to query a database? Check the status of your CI/CD pipeline. Pull data from an external API. MCP makes all of this possible without leaving your editor. The architecture is elegantly simple. MCP servers expose 3 basic operations: initialize, list tools, and call tools. When you install an MCP server, it registers its capabilities with Copilot. Then, using natural language, you can ask Copilot to perform complex operations like create a GitHub issue for this bug, or query our production database for users created this week. The MCP server handles the technical details while you stay focused on solving problems. Setting up MCP servers. Let's walk through how to set up MCP servers in Visual Studio Code. It's surprisingly straightforward. Step 1. Open your settings with Command comma on Mac or Control comma on Windows and Linux. Step 2. Search for MCP Gallery and enable the setting called chat.mcp.gallery.enabled. This unlocks access to the curated MCP server registry. Step 3. Open the Extensions view. Either click the Extensions icon or press Shift-Command-X on Mac. Then type @MCP in the search bar to browse available servers. Step 4. Find a server you trust and install it. For example, you can type @MCP GitHub to install the official GitHub MCP server. Step 5. Test it out. Open Copilot Chat, switch to Agent mode, and click the Tools icon to see what the server can do. You can type the hash symbol followed by the server name to interact with it directly. And that's it. You're now connected to powerful external tools through natural language. GitHub MCP server example. The GitHub MCP server is one of the most useful examples of what MCP can do. Once installed, you can manage your entire GitHub workflow without leaving your code editor. To install it, simply search for @MCP GitHub in the extensions view. Once it's running, you gain access to a comprehensive toolkit for GitHub operations, creating and editing and closing issues, managing pull requests, analyzing commits and code changes, listing repositories and branches, even reviewing and commenting on PRs. Let's see it in action. To list available tools, you'd type #GitHub/GitHub MCP server list tools in Copilot Chat. Want to create an issue? Just use natural language. Create a new issue titled Fix Login Bug with description, users cannot log in with email addresses. The MCP server handles the API calls, authentication, and creates the issue on GitHub. Within seconds, you'll have a fully formed issue in your repository. This is the power of MCP, bridging the gap between AI and your development tools through conversational commands. MCP security warning. Now, before we go further, we need to talk about security because this is absolutely critical. MCP servers are not sandboxed. They run code directly on your system with the same permissions you have. This means an MCP server can do almost anything: query your databases, modify or even drop tables, access your file system, make API calls to external services, execute arbitrary code, and potentially exfiltrate sensitive data. While the GitHub MCP registry is community curated and servers undergo review, you need to take personal responsibility for what you install. This isn't meant to scare you, it's meant to make you thoughtful. Here are 3 essential best practices. First, use official sources. Stick to verified MCP servers from trusted organizations and well-known maintainers. Second, verify the provider. Check the repository, look at the maintainer's profile, see how many people are using it, and read the reviews. Third, review the code. Before installing, especially for local MCP servers, inspect the source code yourself. Look for anything suspicious or unclear. Think of MCP servers like browser extensions or NPM packages, incredibly powerful, but requiring the same level of scrutiny and trust. Always err on the side of caution. Custom Instructions Overview. Let's shift gears to custom instructions, one of the most powerful ways to make GitHub Copilot work consistently across your entire team. Custom instructions are essentially prompts that get sent with every Copilot request, ensuring that the AI assistance you receive aligns with your project's standards, conventions, and preferences. Instead of repeatedly telling Copilot, use TypeScript, or follow our React component structure, you define these rules once and Copilot remembers them. There are 3 levels of custom instructions you can configure. Repository level instructions apply to your entire project and live in a file called .github/copilotinstructions.md. File pattern specific instructions target particular file types. For example, you can have different rules for React components versus API routes. And agent instructions stored in .github/agents.md specifically guide the Copilot coding agent on GitHub. Common use cases include coding standards and style guides, framework preferences, library choices, component organization patterns, testing requirements, and documentation standards. This ensures everyone on your team gets consistent AI assistance that follows your established best practices. Example repository instructions. Let's look at a real repository instructions file. At the top, you describe your project, educational website for sharing homework assignments and coding exercises with students. This gives Copilot essential context about what you're building. Next, document your project structure, where assignments live, where components are stored, where utilities go. This helps Copilot understand your organization. Then comes coding standards. Use TypeScript for all new code. Prefer functional components with hooks. Break UI code into small, reusable components. Follow the dry principle. Don't repeat yourself. Use meaningful variable names, no single letters except in loops. Add JDOS comments for all functions. Finally, specify your tools and preferences. Use PNPM as your package manager, not NPM or Yarn. Prefer Fetch over Axios for HTTP requests. Use ESLint and Prettier for code formatting. Test with Jest and React testing library. With this single file in your repository, every developer gets AI assistance tailored to your exact standards. No more inconsistent code suggestions that don't match your conventions. File pattern specific instructions. Sometimes you need even more granular control. That's where file pattern specific instructions come in. These instructions automatically activate when you're editing files that match certain patterns. For example, you might have one set of rules for React components and a completely different set for API routes. Let's look at React component instructions. You'd create a file called .github/instructions/react.instructions.md. At the top, you specify which files this applies to using YAML front matter applies to /star.tsx and /star.jsx. Then you define your rules. Always break UI code into separate components. Each component should have a single responsibility, be under 200 lines, use TypeScript interfaces for props, include prop validation, and export as default. For API routes, you'd create api.instructions.md and target files in source/API. Your rules might require validating input with XOD schemas, including error handling, returning proper HTTP status codes, logging requests in production, and using async await instead of callbacks. The beauty is that these instructions activate automatically based on context. When you're working on a React component, Copilot follows React rules. When you switch to an API file, it follows API rules. No manual switching required. Now let's talk about custom agents, specialized AI personas you can create for your team. Custom agents are tailored configurations that capture specific workflows, conventions, and expertise. Think of them as different modes for Copilot. each optimized for particular tasks or domains. Here's an example of a front-end expert agent. You'd create .github/agents/frontend.md and configure it with YAML front matter, name, front-end expert, description, React/Vue specialist, and specify which tools and MCP servers it should use, like Codebase Access, ESLint, Prettier, and the NPM registry. In the body of the file, you define the agent's personality and expertise. I am a front-end specialist who enforces React best practices, ensures accessibility compliance with WCAG 2.1, optimizes bundle sizes, creates responsive designs, and uses semantic HTML. These agents work across multiple environments. On GitHub.com, the Copilot coding agent uses them for autonomous background work. In VS Code, you access them through agent mode in Copilot Chat. They're available in the Copilot CLI for command line operations. And if you're part of a GitHub organization, you can define team-level agents in your org.github repository that everyone can use. To invoke an agent, you simply type /agent followed by the agent name, like /agent front-end expert. Now Copilot responds as that specialized persona. Reusable custom prompts. Custom prompts are another powerful feature, reusable task templates that you can share across your entire team. Unlike instructions that run in the background, prompts are explicit commands you invoke when needed. They're perfect for common workflows that you want to standardize and automate. Here's a practical example, a PR summary prompt. You'd create .github/prompts/myprs.prompt.md and configure it to use GitHub tools. The prompt instructs Copilot, search the current repository and list all pull requests assigned to me. For each PR, describe its purpose and details, highlight if it's waiting for review, note any check failures, suggest fixes if needed, and offer to request a Copilot review. Once this prompt is saved in your repository, any team member can simply type /myprs in Copilot Chat, and they'll get a comprehensive summary of their pull requests with actionable insights. The benefits are substantial: consistency across your team, faster task completion, capturing and codifying best practices, and easy sharing and updating. You can create prompts for anything: running tests, generating documentation, analyzing performance, refactoring code, whatever your team does repeatedly. Custom chat modes. Custom chat modes take personalization even further by defining specialized AI personalities for different contexts. While custom agents are about task-specific expertise, chat modes define how Copilot operates more broadly, which tools it uses, its interaction style, and its overall approach to problem solving. Let's look at a database expert chat mode. You'd create .github/chatmodes/databaseexpert.chatmode.md and configure it to operate in agent mode with database-specific tools, Postgres Connect, Postgres Query, and Codebase Access. Then you define the mode's personality and capabilities. I am a database expert specializing in PostgreSQL database operations, schema design, query optimization, and performance tuning. You explain how it helps, analyzing database schemas, optimizing slow queries, suggesting indexes, explaining query plans, and ensuring data integrity. Critically, you also define the response style: technical and precise, always considering performance, explaining trade-offs, and providing migration scripts. This creates a focused, domain-specific AI assistant. When you activate Database Expert mode, Copilot transforms into a specialized consultant who thinks and communicates like a database professional. It's like having expert teammates for every domain: front-end, back-end, DevOps, and security, all available on demand. Best practices and resources. Let's wrap up with best practices and resources to help you get started. When creating custom instructions, keep them concise and focused. Long instructions can dilute the AI's attention. Start with repository-level instructions for broad guidelines, then add file-specific rules only where you need them. This layered approach prevents overload. Always version control your customizations. Treat your .github directory like any other code. It should evolve with your project and be reviewed by your team. Share prompts and agents across your organization. When someone creates a useful prompt, make it available to everyone. Test MCP servers in isolated environments before deploying them broadly, especially if they access production systems. And document everything. Your agents, chat modes, and custom instructions should be as well documented as your code. For resources, start with the Awesome Copilot repository at github.com/github/awesomecopilot. It's a community-curated collection of instructions, prompts, and examples. For MCP servers, browse the official registry at github.com/MCP. And for comprehensive feature guides, the official documentation at docs.github.com/copilot is excellent. The bottom line, GitHub Copilot isn't just an autocomplete tool anymore. With these advanced features, you can create a truly customized AI coding assistant that understands your team, follows your standards, and amplifies your productivity. Start small, experiment, and iterate. The results will speak for themselves. Thank you, and happy coding.